Hi, in this video we're going to talk about the difference between sensitivity and specificity. Let's get started. Let's start by discussing sensitivity. Sensitivity is going to be your true positives, your true positive rate. In other words, how well can the test or the tool detect those with the condition or disease? Let's say you have 100 people that have strep throat, and you develop a test to detect whether or not a person has strep throat, and you administer this test to all 100 people. If your test isn't that sensitive, what's going to happen is of the 100 people that you tested, a small number are going to test positive. So let's say of the 100 people that you tested, 25% or 25 individuals test positive. Your sensitivity is going to be 25%. This is because 25 out of the 100 tested positive for strep, and in reality they do have strep, so they are truly positive. If the test isn't very sensitive, you're going to get a lot of false negatives. In other words, a lot of people are going to take the test, they're going to test negative thinking that they don't have the disease, when in reality they do have the disease. In our example, 75 out of the 100 people tested negative, even though in reality they do have the disease. So these are going to be your false negative results. And as you can see, there's quite a lot of them if the test isn't very sensitive. In real life, this would translate to missing a lot of COVID cases, for example. You could miss a lot of flu cases, a lot of hepatitis A cases, and all these diseases that I mentioned are quite contagious. So if we're missing a lot of these cases, well, then this allows these diseases to spread even further, and we're not able to catch these diseases early on to then provide that treatment early on. So that's why we want the sensitivity of a test to be as highly sensitive as possible. Let's say you make a new test, one that is more sensitive, and so you administer this test to all 100 people, and out of the 100, 90 test positive, and the remaining 10 test negative. This is a much better situation to be in because we're not missing as many of those cases as we were before. To calculate your sensitivity, aka your true positive rate, you take your true positives divided by your true positives plus your false negatives. Keep in mind that all 100 people have the disease, but only 25 out of the 100 tested positive. So those are going to be your true positives because they tested positive and in reality they do have the disease. So they are truly positive. And as for your false negatives, 75 out of the 100 people tested negative when in reality they do have the disease. So your false negative here is going to be 75. Together you have 25 over 100. Simply put, 25% of the people tested positive and in reality they do have the disease. So they are truly positive. In our high sensitivity example, the true positives is going to be 90 because 90 out of the 100 people tested positive and in reality they do have the disease. And as for our false negatives, 10 out of the 100 tested negative even though in reality they do have the disease. So our false negative is going to be 10. So put together, we get 90 out of 100. Our sensitivity rate is 90%. Now let's talk about specificity. Specificity is going to be your true negatives, your true negative rate. In other words, how well can the test or the tool detect those without the disease or condition? So let's say you have 100 people. All 100 people do not have the flu. And so you create a test to detect whether or not a person has the flu. If your test isn't that very specific, what's going to happen is you're going to get a small number of people that test negative. So let's say of the 100 people that you gave the test to, 50 get the results back as negative. Our specificity is going to be 50% because 50% of the people tested negative, and in reality, they also do not have the disease. So they are truly negative. If the test isn't very specific, you're going to have a lot of false positive results. In other words, you'll have a lot of people that take the test, they get a positive result, but in reality, they do not have the disease. In our example, we have 50 false positive results because we have 50 out of the 100 people get the results back as positive when in fact they do not have the disease in reality. And so the problem with a test that isn't very specific is you end up getting a lot of false positive results. And so what ends up happening is you end up over referring people for treatment when in reality they didn't need any treatment because they don't have the disease. And this over referral ends up in time and money and resources being wasted, as well as worrying a person, having them think that they have a disease or a condition in which in reality they do not have. So we want the specificity to be as high as possible as well. So let's say you develop a test that's more specific, and 95 out of the 100 test negative and the remaining 5 test positive. This is a much better situation to be in because we don't have as many false positives. So to calculate the specificity, you take the true negatives divided by the true negatives plus the false positives. In our low specificity example, the true negative is 50 because 50 out of the 100 tested negative, and in reality, they also do not have the disease. Meanwhile, for the false positive, that'll also be 50 because 50 out of the 100 tested positive, when in reality, they do not have the disease. So we get 50 over 100. Our specificity rate is 50%. And so for our high specificity example, our true negatives is going to be 95 because 95 out of the 100 people tested negative, and in reality they do not have the disease. And as for our false positives, that's going to be 5 because 5 out of the 100 tested positive when in reality they do not have the disease. So we end up getting 95 over 100, and what this means is that 95% tested negative, and in reality they do not have the disease. So they are truly negative. So to recap, specificity is going to be your true negative rate. In other words, of the people tested, what percentage tested negative and in reality do not have the disease. If the specificity is low, you're going to have a lot of false positives, and so you're going to end up over referring people to treatment, which ends up wasting time, money, and resources, as well as causing people unnecessary worry because the test is telling them that they have a disease, in reality that they do not have. So we want the specificity to be as high as possible as well. Keep in mind that there's no perfect test out there, and so it's very rare to find a test that is both highly sensitive and highly specific. Sensitivity is going to be your true positive rate. In other words, what percentage of people tested positive and in reality also have the disease. If the sensitivity is low, you're going to have a lot of false negatives, meaning you're going to miss a lot of cases. So we want the sensitivity rate to be as high as possible. That's it for this video. I hope this video helps. Please like, subscribe, comment, and share.